All right, so we're gonna take a slightly different approach. In this case, instead of doing the kind of traditional boardwalk style, we're actually gonna look at another kind of paver pathway where we're gonna utilize a center line curve to start to make some variation to it. So in this case, I'm going to use this surface to create some random points that will use the Voronoi component to create some paver pattern. So let's go ahead and hide those. So now I can go to vector to populate this with some random points. We can always change how many by using a number slider and plugging it into there. Like I said, I'm going to go to the mesh, triangulation, and use the Voronoi component. So again, this is just asking for random point of list, needs a boundary, so I can always use this surface for my boundary. And you can see that it's creating this kind of interesting tile. And for those of you that haven't used this before, let me just plug in a slider here real quick. Basically how it works is that it treats each one of those points as a center point for circles, and then once they start to collide with each other, they start to kind of just create these tangent curves, all right? So they haven't all completely collided until I hit it up to there, right? So that's how it works. Once you kind of get to a certain height, nothing really happens. So here is our pavers. And again, we're going to use this center line to kind of dictate some different parameters. I'm going to add a couple more points to this. So now we're in the 300 range. And obviously we can always mess with the seed value here to randomize it a little bit differently depending on how you want it to look, right? Okay, so I'm going to turn these points off. I don't need to see them all. So we're basically going to measure the distance between all these pavers, so those points, and this curve here. So now we want to, again, reference this curve. And we need to have some points associated with it. So we'll go to curve and just divide it by a certain number. So if we have a higher value, there will it'll kind of keep something a little more kind of flush versus a lower value. And again, you'll see that shortly, what I mean. So I've got all my points, and I want to measure them with this, with all these paver points. So let's go ahead and turn that up. So vector, closest point. So I'm looking at this giant population of points versus this curve here. And this is going to give me my distances and the associated points. Again, I always kind of like to do this to visualize what's happening. So you can plug these two in. You can basically see which of these cells are associated with the points on this curve. Again, it's not going to be used for anything. It's just a visual to help you understand it a little better. I can turn this off as well as this. I don't even need to see this. I'll keep the curve on again so you can see how it works. So again, based on the distances, we're going to start to scale them. So we'll first start off by the closer they are to the center line, the larger they stay. So basically they aren't going to scale any, versus as they get further away, they'll start to get much smaller. So let's go ahead and go to math to remap these values so that we're not using the distances to actually, or the actual distance values to affect the scale, because then they'd get really crazy. We want to remap them to be within that scale of 0 to 1, which is what this is defaulting to. And again, I like to use the graph mapper to affect how these scale, so it's not just a linear scale interpolation, but rather something slightly different. So we'll start with the Bezier, and again, if it's really close or it has a 0 value, it's gonna stay near the, we want that to stay almost the same size, but then as it gets further away, so when it gets remapped towards that 1, we want it to scale more. And I probably don't want it to scale to 0, just so that there's something left and it's not just kind of missing. So we'll have this kind of S curve here. Now I can use the scale. So what I'm scaling is these cells with these center as their center points, right? So by default, they just have a scale factor of 0.5, which kind of looks interesting, but we want this center line to affect their scale values. So I'm going to turn this off, drag this into here. So now we can see that, again, the ones that are really close are going to stay the same size, and then as they get further away, they start to get smaller. So we can obviously affect how that transition happens. If I want there to be more that kind of retain that scale, you can keep dragging that there. If I want there to be more that get really small, I do it like that. If I want it to be something kind of more gradual, I can start to play with that. Again, this gives you a lot of flexibility to do that, right? So we can start to see how that transition happens. And what's cool is if you want it to be the opposite, you could always just drag these over. Again, I don't want it to be 0. If I want it to actually, instead of it being a pathway, if I want it to be something more of kind of like a channel for water or whatnot, I could always kind of do it like this to have some stabilizing rocks on the edges, and then this is a little more kind of uninterrupted. But I do want to get rid of some of these small ones. Sometimes you might want to just find that kind of threshold where, yeah, like once they get so small, they're really unnecessary. So we can play with that as well by adding a operation to remove all of those really small pieces. I'll go ahead and shift this back to this so that it's more of a pathway. And like I said, I just want to get rid of the ones that are really, really small. So all the kind of pieces all the way on the outskirts here. I want to make this a little bit wider just so we can have a better kind of transition. So let's just go ahead and take this surface and scale it out a little bit more so it's a little bit wider, right? Go ahead and hide it, and with that, let's also add some more points. Okay. Alright, so like I said, I want to start to filter them out once they get really small. So I can go to, let's do area. So we're going to base it off their size. So this is going to give me the actual size of all these curves as well as their center points. So we can see that. So we're basically going to say, once they get so small, just go ahead and filter them out. So let's go to sets, or sorry, math, smaller than. So if it's smaller than a certain area, then we get rid of it. If I want, I can look at just what these values kind of are, because I don't know off the top of my head what they're going to be. So they're between 7.7 square feet and 0.02. So let's start off with something like 2.00. So anything less than that value will get removed. So sets, list, dispatch. And the list that I'm going to look at are these ones that have been scaled. I use this pattern, so everything that's smaller than, we can see is going to be in the A. Let's get rid of this too. And everything that's large or than that will be in the B. So we actually want to keep a B. You can obviously use the larger than as another, and then it's going to come out of the A, but this is what we chose. So if I want to include more, I could always increase this. If I want there to be less, I just keep dragging that over. So that's how we can, again, kind of start to filter some of these things out. So yeah, I want it to be something more like this, and then yeah, I don't know. Let's yeah, I mean, like I said, you can really kind of play with it to get a certain result from it. Okay, so I don't really need to see this surface anymore. Let's get rid of it. All right, so that's what it's looking like. So again, the idea is that you want this to be something with some volume. So now we can take our curves, convert them to a surface, then extrude the surface. Oops, keep it enabled, just turn it off. And we're going to go to the Z. And again, these will be something like 0.2. All right, so now we got some thickness to these. And again, what's cool is I can, with this curve, turn their points on and start to move it around, and everything will adjust accordingly. All right. And what's cool is right now I just have a single pathway here. If I wanted to add maybe even like some secondary pathways, let's just get this to actually undulate a little bit more. Remember, I've got a lot of surface here. Let's actually now make it a little bit larger, or sorry, longer too. So like I said, maybe I want to also add kind of a secondary path to this, or at least something, right? Let's just manipulate this a little bit more. I'm going to drag this down so there's a little bit more of a gap right here. You'll see why shortly in a minute. So like I said, maybe I want to add an additional curve, so I can always just go to here and kind of make it so it's tangent or connected, and have it merge back to this. Now I can select both of these. I'm going to go ahead and flatten this because I know that's what's going to happen later. So I'm going to say now set multiple curves. And now we've got it looking like that. So now there's kind of a cool little pocket in the middle there. And if I want to, again, kind of add more to it, I can always drop the cell size. All right, it's starting to lag a little because once you start to make it into a surface and start extruding things, it just requires a little more processing power. But here we go. Now we've got an interesting kind of paver pathway with this kind of dissolving quality of these stones based off of, again, a center line. Let's just do one more thing real quick. So again, I always like to kind of get it to, or show all the kind of value to it. So based off of the area of these, maybe I can even start to give it some color association too. So I want to use the pattern still to dispatch the area values now. So I can actually use just the filtered ones, right? If I just use all of them, I'm looking at 475 versus 350 roughly. So it's important that you use this for everything kind of moving forward, because this is basically you're filtering out all the data. Obviously I can just do an area from here too to work if I forget that, but we just have to remember that everything that gets pulled out of B, regardless of what we're using, everything should be coming out of the B as well. So now I have my areas. I can go to parameters, use this gradient tool. Let's change that to this kind of gray tone. So here's all my values. And now I'm going to look at that domain. So the highs and the lows, so that we understand which one should be which. So here's the lowest value of 0.53, which no surprises should be right around that, versus the end domain, that's the largest one. So basically the larger ones are going to be dark and the smaller ones are going to be white. And maybe I want it to be slightly gray, so I can darken it a little bit, right? So now it just goes from black to a light gray. And again, if I want this to actually read in Rhino instead of just through Grasshopper, I can always convert these to a mesh and colorize the mesh. So I'll use the B rep from mesh, right? And then I can colorize it here. So mesh colors, drag this into there. Oops, so we want to again kind of, I'm going to lock this real quick. Basically you want each mesh to get its own designated color based off of that order. So I just want to graft it so it works that way. So now I can unlock it, and now we can see that, again, the ones that are the largest are going to be this black. Maybe I'll just make it slightly gray, right? So now we have from light gray to dark gray. It starts to look more like a interesting paver. Now I can bake that. And now I've got my pavers, so there we go. So again, a fun tool to create pavers a little bit differently and have them more kind of like the stone pattern.